Okay, welcome back, geometry. Let's give you some examples of how to put this Pythagorean theorem stuff to use. This probably won't be a very long video. Let me dig up my examples. Pythagorean theorem and its converse theorem. Okay, so we already did an example of how to use the distance formula. If you had to find the distance between 2 points, we could do another one and pick the distance between two other points if we wanted to. But for some examples here, we're going to go example A. It's going to just say solve for x. Solve for x in this picture. We got right triangle. I'm going to put a 5 here, 12 here, and an x. Pause the video, try it yourself. Come up with an answer. Pythagorean theorem. It's got to be a leg squared plus a leg squared equal to the hypotenuse squared. So the x could be in any one of these three positions. But it's 5 squared plus 12 squared equals x squared. 5 squared equals 25. 12 squared equals 144. And x squared, add those two together, we get 169. Square root either side. And you may not recognize it, but you should always try it on your calculator first. But that is a perfect square. That equals 13. It's technically plus minus, but we are talking about the side of a triangle, so we're not going to mess with a negative at all. The answer is just going to come out to equal 13. The answer is going to be 13. So there's my first example problem. Let's try example B. Example B, it's going to say find the perimeter of, find this perimeter of this rectangle. Find the perimeter of this rectangle. So it's going to go like this, across, one big old diagonal. All right, let's see. This is going to say 10. It's going to say 6. Okay, so pause it. Try it yourself for a minute. Try to figure it out. You got to find the perimeter. Remember that the perimeter is adding up all the sides all around. So the biggest clue in the directions is that, hey, it's a rectangle. It's a rectangle. So that means opposite sides are congruent. Bottom is 6. Top has to be a 6. It's the left and the right we got to figure out. The other thing is that when it's a rectangle, every corner is a right angle. And so you can take this triangle standing up, say, hey, that's 6, that's 10. This is x. We don't know what this is, this side. Pythagorean theorem, x squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. Subtract 36, and lo and behold, it's a perfect square number. Square root both sides. X is going to equal, it's plus minus, but we're just going to count it as 8. That's not the answer to the question, though. This side's 8 and this side's 8. And so the perimeter is 6 plus 6 is 12. 8 and 8 is 16. 16 plus 12. Why do I have to think about this so much? 16 plus 12 is equal to 28. Boy, I had to think about that way too much. I'm doing my video a little too late at night. Let's move over to example C. That color's a little too light. Let's get one a little darker. All right. Example C. Find the perimeter of this trapezoid. All right, so it's not an isosceles trapezoid. They would have told us that. The top part's going to be, well, let's see. Top part is going to be 35. Bottom part's going to be 42. The right side is going to be 24. And that's it. That's all they're going to tell us. So we have to find the perimeter. We have to find this missing side. And think about it for a minute. If we're in class and say, hey, all right, guys, give me some ideas. What are we going to do? What are we going to do? These two right angles at this end is kind of a hint. And this is actually kind of a step that we do quite often. We drop a line in here and make it perpendicular to create a rectangle on one side, on the right side, and a right triangle on the other side. Well, how is that helpful? Well, if this is a rectangle, you got the 4 right angles. This is a rectangle, then opposite sides congruent. This has to be 24. Okay, but I still can't do the Pythagorean theorem unless I have 2 out of the 3 sides. And that's where these two numbers come into play. If that's 35, then this side of the rectangle is 35 from here to here, meaning this part has to be 7 to get 42. Ah, sneaky, sneaky. All right, so 7, 24. What's this side? You got to do Pythagorean theorem. So 7 squared. The hypotenuse is missing, so 24 squared equals c squared, or x squared, or whatever you want to call it. But I get 49 plus, I got to remember this one, huh? 24 squared. 24 squared. I'm going to use my phone. I should know this one, though. I really feel like I should know this one. 24 times 24, it's like 570. Yeah, 576. Truth be told, that's what I was thinking it was. All right, if I add 49 to that, what's going to happen is I'm going to get a perfect square number. Probably not one you recognize. Is equal to c squared, but if I were to square root here and here, that actually comes out to equal 25 for the hypotenuse. So this side is 25. Now I can add them all up. So it goes 25 plus 35 plus 42 plus 24 for the 4 sides of the trapezoid. So 25 plus 35 plus 42 plus 24 gives me 126. 126. Get another pen here. Let's try another example. Example D. Acute, obtuse, or right. What kind of triangle is it if it's got sides that look like an 8, a 12, and a 13? And I'm making it look acute, but I really don't know what kind of triangle it is. So you have to try out the Pythagorean theorem. Is a squared plus b squared, is it equal, is it less than, is it greater than the c squared part? How do you know which number is which? Well, if it's a right triangle, the biggest number has to be the c squared. Okay, that helps us. That means the 8 and the 12 is a and b. So 8 squared plus 12 squared, how does that compare? I shouldn't put c. How does that compare to 13 squared? 8 squared is 64. 12 squared is 144. 13 squared is 169. Well, I could tell you already. As soon as you add 60 onto 144, you're at 204. Add 4 more, you're at 208. And that's definitely bigger than 169. Now, you have to keep in mind, it's definitely not a right triangle. You can eliminate that because it didn't come out equal. The trick is like, hey, how do I know if it's acute or obtuse? And the way I like to think of it is, if it's a right triangle, if it is an actual right triangle, then this squared plus this squared equals this squared. When it doesn't come out equal, if the c squared part is bigger, then they would make this side longer, and that would create an obtuse triangle. But in this case, the c squared part came out smaller. So it goes from being a right triangle to being smaller than a right triangle, an acute triangle, if you had to make the c squared part smaller. So this is an acute triangle. All 3 angles are going to end up being acute if you have measurements of 8, 12, and 13. There's an example of using the converse of the Pythagorean theorem. All right, so we have distance formula, Pythagorean theorem, converse of Pythagorean theorem. There's all my examples for you. We've done a little bit of each. If you guys have any questions over these two videos, please shoot me an email. Let me know.